Hi everyone, so in this video we're going to be going over a rational function, the asymptotes, and how to solve for a vertical asymptote. So what exactly is a rational function? So a rational function is a function on the form of a form, I'll just say f of x equals to g of x, so a polynomial on the numerator and a polynomial on the denominator. And of course, the restrictions being that h of x cannot equal to 0 because a 0 on the denominator makes it undefined. So what are some examples of a rational function? So I'm just going to give a few examples. X, I'll say that, x plus 2 over x plus 1 over, that's one example. One can be 2x squared minus 3x plus 5, because that's technically over 1. Both are considered a function. So an example of one that would not be a rational function would be something like this. I'd say 3x minus 2 over square root all over x plus 3. And the reason why this is not a rational function, because here, this one, square root x plus 3, square root all over x plus 3 is not a polynomial. So now that we have an idea of what a rational function is, we can learn about what asymptotes are. So I'm just going to go here, and I'm going to just draw a quick grid. Here. A little tricky, but there, that's perfect. So I'm going to use an example of f of x, equals to 1 over x. So if we were to put this in our graphing calculator, the shape should be something like this. It goes really close to the y-axis and drops down over to the x-axis of 0. And the same shape on the other side. It'll go really close to there. Go here. So I'm just going to give the example of an asymptote over here. Is, you can say an asymptote is a vertical or a horizontal line that a part of the graph gets very close to but never reaches. So when we talk about asymptote, we can have a vertical asymptote and a horizontal asymptote. So when we look into this graph, a vertical asymptote will follow a vertical line. So as we can see, if you were to look on a graphing calculator, you'd notice that it will go up, 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 and really close to 0 on here. It will go really close to 0, but it will never fully reach 0. And same here. Down here, it'll go down, down, down. It'll become smaller and smaller and smaller. The smaller and smaller, here, the x value, but it will never become 0. So your asymptote for your vertical line would be here, because it comes closer and closer to 0, but it never reaches 0. So your vertical asymptote is 0. Do that in a 5px. Right. And your horizontal asymptote is also at 0 on the x-axis. because we can see here that it goes on or on Desmos or on your graphing calculator, that it goes down, 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 down here, but it never touches 0, and also here it goes up, 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 but it also never touches 0. So your horizontal asymptote is 0. And now that we have an understanding of what asymptotes are, I'd like to do another function. Alright, I'm going to just make another grid. I'm going to do that color. I'm going to do a new color. I'm going to do maybe this color. I'm going to say f of x equals to 1 over x minus 1. Alright, so since the denominator of a rational function can't be 0, it's the zeros of the denominator which restricts the domain. So in this sense that whatever the denominator, we have to find out when I'll say x minus 1, the denominator, when it equals to 0, whatever x value is, that'll be our vertical asymptote. So I'm just gonna rewrite it. I'm gonna do vertical asymptote. Okay, so I'll do another color. So x minus 1 equals to 0 plus 1 plus 1 and x equals 1. Since our vertical asymptote is at 1 here, right? We're going to put our 1 right. We're going to locate 1 on the grid. I'm just going to draw it here, not the scale. And then boom. So our vertical asymptote will be at 1. And just for the sake of this video, since we're only going to be exploring vertical asymptotes, this horizontal asymptote here is just at 0. In the next video, I can teach you how we can get 0 from here, but for now, we'll just focus on the vertical asymptote. So here's how our graph would look like. So as such, we're going to only be focusing on the vertical asymptote. So we can see here that during this, during this part, so at this kind of area right here, right, that it's going to go up and up and up and up and up, but it'll never cross 0. I mean, it'll never cross 1, and your x value will never be at 1. And same here, it goes down and down and down and down and down, more down and more down, but it'll never intersect nor touch at 1. You can also write your vertical asymptote in the sense that like VA equals to 1, or you can say that as your restriction that x cannot equal to 1. That's one way you can write it. I'm going to put this a little bit to the side. Alright. Now we can't always now you probably noticed that with this graph and this graph that it just shifted by 1 to the right. Now we can use transformation as a way to help us. There's some times where it can be a little tricky. So for the next 2 questions, I'm not going to use a graph. I'll not draw the function, but I'll just show where the asymptotes will be. So I'm going to just say, for example, a function, just down there. I'll say, let me use another color. I like. Let's use green this time. I will say that f of x, I'll put this to the side, f of x equals to x minus 2 over x squared plus 2x minus 3. I'm actually going to just move this a little bit to the center. Alright, there's a function. So as we say, we have to find out what x value equals when this denominator, the polynomial on the denominator equals to 0. So what we do, take this entire thing and make it equal to 0. So your VA So this will become, gonna move a little bit to the right. Okay, it's gonna be right. So what color do we use? Yeah. So x squared plus 2x minus 3 equals to 0. So you got that there. Alright, so now since this is a quadratic formula, we can try to use factoring. Sometimes we might have to do quadratic, but for things I'll just keep it simple. So we got negative 3 and positive 2. I'm gonna say, so the factor could be 3 times negative 1, and then 3 minus 1. So that will be x squared minus x plus 3x minus 3 equals 0. We factor this part both separately. This becomes x over x minus 1, then 3x minus 1. So this becomes x minus 1 and x plus 3. I'm going to zoom out a little bit so that's more room. So then your your vertical asymptote will be, you can probably figure out it's at positive 1, because 1 minus 1 is 0, and then negative 3, 3, 3, and of course you can say, or instead you can say, x cannot equal to 1 or negative 3. So if we were to put this on a graph, right, I'm actually going to take this entire thing, move it to the side, and I'm going to just quickly use some black paint, black fill. Alright, so, I'm going to draw the grid. Boom. Boom. Right. So it's at positive 1 and negative 3. So the positive 1 and negative 3 a little to the far side. Negative 3 here. So, alright, I'm going to use a larger brush to illustrate. So our vertical asymptote will be at 1. So it will be here and here. And then negative 3. I'm not going to draw the function, nor am I going to find the horizontal asymptote. Just wanted to show where the the vertical asymptotes will be. So let's move on to a little slightly more trickier, but I promise a much more fun one. Alright, so I'll say, I'll actually go back to original size. I'll say f of x. Alright, sorry, it's got this moment. Alright, I'll say f of x equals, let me think, 2x plus 3. 2x plus 3 over x cubed plus 4x. Again, all we have to do is take the denominator and make it equal to 0. So I'm going to move this to the side. Say x cubed plus 4x equals 0. We can factor out the x. This becomes x squared plus 4 equals 0. X here, and then x equals 0. X squared plus 4 equals 0. No, we'll say equals negative 4. So as such, we cannot square root a negative number, so no real answer. So our vertical asymptote will be at 0. Sometimes after factoring out, it'll not result in two vertical asymptotes. Sometimes you'll get a situation like this. So as such, it'll be yellow brush. So it's at 0, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, that's just about it. And next video, we're going to be covering how to solve a horizontal asymptotes of rational functions. Stay tuned, and thank you for watching. Hope you understand.